I've been preparing the launch of the Model S for a while now, my new circuit board, and I plan for that to be my next video, but I realized that the new firmware I've been working on should probably come first, since I really want a lot of those new additions to be present on this batch of boards that I'm shipping out. Also, my fabricator, JLC PCB, happened to ruin 142 out of the 240 that I ordered, so that also put a damper on the Model S release. I'm currently trying to get a refund from them, and I've taken it to PayPal. JLC just gave me a bunch of excuses that were incorrect, so. In the midst of the fiesta, though, I have a bunch of other really cool stuff that's about to be finished. So, we've got the USB-C mod for GameCube controllers. I have a Raspberry Pi Pico controller that's almost finished. And I'm just starting to work on a replacement PCB for GameCube controllers as well. I'm not 100% sure what order all of this is going to be in, but if that sounds interesting, then you'll probably want to stick around. Anyways, here's a bit of a rundown on the new firmware. I'm calling it CLFW for Crane's Lab firmware. Let's go over the few new features that this firmware has over my old one. Melee functionality has been updated to mostly match box V3, with the most notable changes being shield tilting with mod X instead of R, which is a good bit more intuitive, some coordinate changes, and I have added extended up B angles for characters that need those. I've also added a mode that has the left-hand outputting D-pad commands, which is useful for PC fighting games, platformers, and even the Game Boy player on GameCube. I made it so the firmware automatically detects if you are connected to a PC or a GameCube, whereas before you had to hold a button while plugging in to choose one or the other. I added an N64 mode, which you can use provided your controller is able to run on 3.3 volts. As a heads up, standard Arduinos like all of these, they're not able to use this mode because these boards require 5 volts to run. But if you use any of my hardware besides this GCC PCB one, so the 2, Model S, or even the box, then you'll be able to use this mode because all of these can run on 3.3 volts, which is what the N64 outputs. Finally, I added the option to use a different button layout for each of the game modes if you so desire. If you're seeing this video sometime in the future, there's probably been more features added, so check the GitHub README page to see a full list. For example, I plan to add a USB mode for the Nintendo Switch. There's this tool called Platform I/O, which is an extension for Visual Studio Code, and it lets you set up different configurations for your firmware. You can select which hardware configuration you're using, and then it will pick which files it needs to define your pinout and your hardware's capabilities. So your Arduinos that don't support USB, and the Hitbox Smashbox, which just uses one of these, they don't have the USB flag set, so all of the USB functionality just gets disabled. Currently, all of the AVR Arduinos that you see here, all of my PCBs, the H-Tangle, the boxes, the Hitbox Smashbox, and any other controller that ends up using an AVR microcontroller, they just work with the press of a button. They all use the same exact logic files, so if I ever need to change anything or add a new mode, I just have to do it once. On top of this, I've designed the code in a way that all of the hardware architecture stuff is contained within its own API. Talking to the GameCube or PC, reading the buttons, outputting to an input viewer, this is all stuff that requires platform-specific code. By having it separated from the logic in the game modes, it will make it so much easier to support other platforms using the same codebase. For example, you have the Raspberry Pi Pico and even the STM32 that is used by the Frame 1. I'd like to eventually support all of these devices, and it will be a lot more convenient now to maintain the firmware since it's organized like this. With all of that said and done, I'm going to show you a quick installation guide since the process has changed quite a bit for the better since my last video. Do note that if you're watching this sometime in the future, check the installation guide on the GitHub repository to see if anything has changed. It will probably remain the same for the most part, but I figured I would mention it just in case. So the first thing we need to do is install Visual Studio Code, and you can install it for Windows, Linux, or Mac OS. And once you have that installed, you're going to open it up, and you're going to want to go to the Extensions tab and search for Platform I/O. There will be a button here that says Install. You're going to want to go ahead and install that. And then you'll get this menu show up on the left here. So once you have Visual Studio Code and Platform IO installed, you are going to need to download the firmware itself. There's two ways you can do that. You can either go to the release page on the GitHub repository, or you can use Visual Studio Code to clone the repository. I think it's better to clone the repository because then it makes it so you can just automatically download updates. So I'm going to show that here. So if you hit clone repository and then clone from GitHub, and then you just type in CLFW or probably Crane 1195-CLFW, you'll see it show up. I'm going to use this demo folder. Hit select. It will clone it, and you'll get this message in the bottom right. Go on, hit open. And if you have this pop up, you can just hit don't save. Hit trust this author. So now you're going to have the repository open in here. And if you hit this button down here, this will fetch from the Git repository. And anytime there's changes made, you'll have like a downward arrow that you click, and that will pull the latest changes into your repository. So to update your firmware, you just have to click this now instead of re-downloading it from the website. So the next thing you're going to want to do is open up this menu and select whichever one of these hardware configurations you're using. So let's say you're using an Arduino Micro, you would just click here. And if you use any of the Arduino ones, you're going to go to the hardware folder and then open Arduino diy.h. This is where you define your pinout for the controller. And all of the Arduino ones, they use this pinout file. And then the rest of these, they have their own pinout file, which is preset for that hardware. So your Model S and GCC PCBs, etc., they use a preset pinout based on where the Brook board is going. And then the Smashbox, Box, H-Tangle, and GCC MX, they have their own preset pinouts. So for those, you won't have to change anything. But if you have your own Arduino and you use a pinout that's different from this one, this is where you'll be changing it. And just a couple of notes. If you aren't using a button, you would set it to be 255 here. That will mean that the code will ignore that button. So this is a left shoulder button, which most people will not have a specific button for. That would be like a left Z button. Select and home, some people don't use that. And another thing to note is that R2 is right trigger for a GameCube controller, L2 is left trigger for a GameCube controller, and then R1 is the Z button of a GameCube controller. So you set your pin out here, and your console data pin is right here. And then once you have your pinout in place, all you have to do is plug in your Arduino of choice and hit the upload button. So let me grab a controller right now. Okay, so I went ahead and plugged in a GCC-MX because that's what I have on hand. So I will switch back into that mode. And then if you want to see that your controller is showing up, if you go to the Platform IO Devices panel, you can see your serial ports here. So I can see COM19, that's a USB serial device, that's my controller. You'll sometimes see something like COM1, that's usually just your motherboard. But since we have the controller here, we have our platform open. All you have to do is hit upload, and then your terminal will show up. And you'll see it compile and start to upload. And there we are, now it's done. It'll automatically select the correct port and the correct hardware based on which of these you chose. So if you use one of these Arduinos that don't have native USB, it'll just disable all of that functionality. So the final thing we want to do is grab the INI file that's in the setup folder and copy that over to our Dolphin user config profiles GCPad folder. You might need to create these last two folders if they don't show up already, but you can just create these folders, drop this file in here. And now when you load up Dolphin and go to your controller tab, you'll see it show up in here, and you just select it, hit load, and then all of our buttons will get picked up as they should. A few final things to note is that there are different game profiles and device modes on the firmware. So when you plug into a GameCube or a PC, then you don't hold any buttons. And if you're plugging into an N64, you'll hold C up. And if you're plugging into a PC and you want keyboard mode, then you hold Mod Y. And also, if you are playing Ultimate, you'll hold B, PM you'll hold X, Rivals of Aether you'll hold Z, and you'll hold up for a fighting game or D-pad mode. And these modes can be combined together as well, so if you end up setting up a specific N64 mode that is holding Y, for example, you can hold Y and then C up to enter the N64 mode of your choosing. I'll also mention that this firmware is compatible with the input viewer on this GitHub repo. I would highly recommend checking this out if you want to use your controller with an input viewer for a stream or for demo videos or something like that.